from Japan. I would like to comment for one small thing. On page 8 in your slides, it said that these two outcomes, X star and Y star, have proportional outcomes.
Yes.
In your slide, page 8. But I think these two likelihoods aren't proportional because the coefficient C of multivariate normal depends on mu. So it's not constant. So I think
I'm prepared to say that take any example that you agree is a likelihood principle violation. Because some people do the optional stopping in different ways. This is their example that they use to kick off this. But we know that there are zillions of LP violations anytime you use a p-value or an error probability, you're violating it. So you'll take any one if you don't like this one. Binomial and negative binomial is probably the simplest one.
yes, binomial and negative binomial holds proportional likelihood.
So take that one. Then take that one. I mean, nothing of what I'm doing today will turn on that. Take any LP violation.
Oh, thank you.
Okay. But as I say, this is actually the example they give and comes straight from Berger and Walport, from Edwards, Lindman, and Savage, from Cox and Hinckley, from Casella and Berger. Oh, and on the supplement, you will see why Cox sees it as the only difference is the coefficient. I was going to put that up, but I figured I will just give that supplement. Other questions?
Yeah, I have a question. So it seems that this is what's going on with social psychology irreproducibility right now, that they will conduct a number of small experiments until they find one that shows p less than 0.05. Then they'll just report the single experiment that they found with p less than 0.05, not talking about all of the other experiments they did that showed nothing. So they're reporting X star, although they observed a whole bunch of other things that I'll lump in with Y star. Is that a reasonable comparison?
Actually, I think it's something else going on there. And once again, I'm sorry, I don't see your picture, that's a kind of cherry picking or selective reporting, which will blow up the error probability for sure. But not a case, I'm not sure how I see this as a case of either an LP violation. I see what you're saying, okay. If you do ignore the overall error probability the way an LP person would, then you think it's perfectly fine to just select and report whatever outcome. I won't say that everybody who holds the LP would agree to selective reporting, however, but there is that connection. I'm gonna do something with my pictures because, okay, so I agree that there is that point. Ignoring error probabilities can be very dangerous. And of course, the optional stopping has been seen to be a very big problem with irreplication. If you do accept the likelihood principle, you would think that there's nothing wrong with just reporting it as if the sample size was fixed all along, even though in fact your error probabilities accumulate. And in this particular example is designed deliberately to be one where you know you're going to stop and erroneously reject the null hypothesis. Jim Berger gives the analogous version using confidence intervals that you can, by the same dint, keep sampling and your interval will always exclude the true value of 0. And he says, well, that's true. But he'll say you may have had the wrong prior or something. Other?
Yeah, I can ask something. I originally came from robust statistics, right, where we are interested in the question, if we assume a model, what happens if the model is actually not fulfilled and the model is maybe violated in only small ways, so that something happens that is maybe still close in some sense to the model, but the model is not necessarily fulfilled. And then what can we do in order to come up with good rules for inference so that we have some safety in these cases, so that we can mathematically prove something like, if the model is violated in this or that way, we still what we get is not so far away from what we get under the assumed model. Now, if you come from this angle and you hear about this Birnbaum theory and the sufficiency principle and the conditionality principle and the likelihood principle, the first thought is, this is not really relevant for us, because if you are willing to look at some alternatives to the model, so not only to constrict yourself to the model that you are assuming, then already the sufficiency principle and the likelihood principle are out of the window, right? Because both of these principles basically assume that you got to take the model for granted and that you cannot basically take into account the possibility that the model is something else. Given this background, I'm wondering what you think what the role of such general principles actually is. So do you think that the sufficiency and the conditionality principle, which you would be willing to accept in the way that you reconstructed them, that they actually are something that statisticians should stick to, which I would say I would basically doubt in the first place?
Yes, this is the objection raised by Bross and Kempthorne also in the supplements, saying that it's ridiculous to even start out assuming the model, or even assuming that we are doing inference about parameters within the model. But of course, most of the controversy, or at least a lot of it, in statistical inference for a long time had to do with different ways of making inferences within the model, what Birnbaum calls informative inference. And so he was restricting himself to that. In terms of whether it's important to worry about these principles, I don't know. I think now that it's been disproved, I hear a lot of people saying it was never important anyway. And if you really try to pin them down, it's a lot harder to characterize them in an unproblematic way. So is that a good answer? This Christian, right? I recognize your voice,
well, yeah,
though I don't see.
Well, to be honest, it doesn't quite address my point, which is, what do you think about how these principles, or whether these principles should actually be used and respected by statisticians, or whether you'd rather agree to say that, of course, thinking about them is worthwhile. I mean, I'm not doubting that, right? I'm not doubting the value of this work, but the other question is, to what extent are they really proper guidelines for applied statistics?
Well, I thought I did address that, and I'm prepared to say that, this seems like a toy, inference. We're never even in that situation. My concern is only to show that this is not a theorem, and we have textbooks that will call it a theorem still. And I also think that no matter what we say about the fact that we're rarely in that enviable position, in the back of people's minds, if they think that they can't use error probabilities because something has been proved to show that they're appealing to something that's strictly irrelevant to inference, then, you know, that's a problem. So this came up in the discussion. There was a discussion around this in statistical science around my paper, and that was one of the things. And some of the other people were people who like modern day versions of fiducial arguments. And they were saying, of course, it violates the likelihood principle. And I'm so glad she's cleared that up or something like that. As I mentioned, non-subjective or reference Bayesians also say they have to renounce the stopping rule principle and the likelihood principle. And it's interesting, I'm not sure how they get out of this argument, but they want their priors to be allowed to depend on the sampling distribution. So, other questions?
Deborah, can I ask something? This is Peter Grunwald. Hi.
Hi.
Yeah, I have two things. One is maybe I have an answer to Christian. So I think that the importance of these things is, it really depends on the methods you're using. But if you're using really very simple methods, just standard Nijman-Pearson hypothesis test, these things do say, if they would be correct, that in the idealized circumstances, which may never hold, but still in idealized circumstances, something goes wrong. And I think this is very important, because it's like you build a new car and you test it on a super nice straight road and it crashes. And then somebody says, hey, but that doesn't matter, because in reality, our roads are never so nice and so straight. It does matter, right? Because if even in idealized circumstances, something strange is going on, then this is an indication that more generally, it's still kind of tenuous. So that would be my answer to Christian.
I see, yeah, thank you.
But of course, well, I'm not sure if I've completely followed your argument, but I would like to add one thing here, which is kind of in defense of Bayesians, whether or not the likelihood principle holds. The evidence you get against the null in the simple example that was given here, if you use likelihood ratios, is in a sense is smaller if you use Bayes factors than if you use p-values. So in that sense, it's true that they would get the same inference in both experiment 1 and experiment 2, irrespective of how they got to that sample size. But their conclusion would be much weaker than the strong p.05, so that being significant. So I know
what you're saying.
In itself does not show that Bayesians might be overconfident or anything like that.
Yeah, this is a very, I mean, people don't do this kind of thing. He's really trying to show that these two are equivalent, no matter what the numbers are, that they ought to be evidentially equivalent. And we don't tend to talk that way so much anymore. But with respect to this point about Bayes factors versus p-values, which I talk about a lot elsewhere, of course, that mismatch results from giving a high prior probability to the null hypothesis. You could, in fact, get matching, right, posteriors and p-values with the diffuse prior. So that's a different issue that we can talk more about. I said that this wasn't...
That gets very technical. I was thinking about the Bayes factor method, where indeed,
I am too.
And I don't think of that as it's complicated, because I don't think of that as a real Bayesian method, but rather as something else.
It may not be. We actually had a few sessions on it. But I think it's distinct from this point. But whether you do better on a Bayes factor, is a distinct question. I don't think so, because those results that show the difference and show a radical difference, that show people say p-values exaggerate, the evidence against the null, wind up giving a high spike prior to the null hypothesis. And that's not really warranted. But again, this is a different point. And I said at the beginning, I consider that this is not in the form of our usual presentations for this. And it isn't something that I will give if we ever have that workshop, because I really am interested in current controversies. On the other hand, this is creeping up again sometimes. And I can tell from papers that I'm asked to review. And because I go through it every year around this time on my blog, I thought I would do it.
Yeah, can I just make a comment about the Bayes factors? I think that those methods tend to be very, very conservative, which is to do with the likelihood as much as anything. The problem is that the area in which the parameter can vary under the null hypothesis is usually enormous, and a lot of it will be irrelevant and a long, long way away from any point estimate you would actually have. On the other hand, the null hypothesis has a huge lump and mass of probability, which usually is not too far away from the point estimate. And that means it's not so much a question of the prior probability of the null or the prior probability alternative. It's simply expressed in terms of likelihood ratios. It's very, very hard to fight against such an attractor. And I can think of a number of circumstances myself where I work as an applied statistician, for example, on a data safety monitoring board, where I really wouldn't want to have that degree of conservatism about side effects or something like that. I think the behavior of Bayes factors is really, really strange. So
have you written on
I
this,
have
Stephen?
Yeah, I have written something about it on one of your blogs on your site, Deborah.
Oh, okay, but yeah.
But I mean, that's
No,
not to
I would
say,
like to.
I mean,
Yeah.
in general, Bayesian methods tend to be somewhat conservative in the sense of pulling things towards prior experience. I have no problem with that, but Bayes factors themselves are behaving in a very strange way. I'd like to make another point, and that is to say, well, 2 points. First of all, I think that many frequentists or applied statisticians anyway, even if they work in a frequentist regime, will keep an eye on likelihood and will stop to consider whether they're doing things which appear to be strange from a likelihood point of view. And so one could say that from that point of view, the practical statistician is not necessarily in need of some sort of a proof that likelihood is a good thing to be looking at. The other point I'd like to make is that as regards optimal stopping rules, it depends very much whether you're going to make a decision which is irreversible based on the single experiment you're running, or whether they're simply going to contribute to some body of evidence. If the latter is the case, then even as a frequentist, you don't need to take the stopping rule into account.
If you don't plan to make a decision, is that what you said?
No, if you're just contributing an experiment and everybody's honest and, for example, your experiment stopped early, what that will mean is that that particular experiment will post a lower sample size. That means it will be weighted rather less than it would have been had it continued to the end. Now, I have a paper in Pharmaceutical Statistics showing that if you're a meta-analyst, you do not need to take into account the fact that trials have been run sequentially. It makes no difference. Mm-hmm. But there's a problem with, single one-off decisions cause difficulties for statistics in general, I think. But that's a different case.
Well, as I say, this is one of the classic examples, but you could use any LP violation, and in fact, use an error probability, you've got an LP violation. So this is just a dramatic example, and it's one that always comes up, although there's disagreement as to who it's showing a problem for. The frequentist thinks it's showing a problem for somebody who won't take that into account. So here is the casualties that I started out with, that the likelihood principle is incompatible with the main body of modern theory. And so you don't have to go to exotic examples. And I think, yeah, part of the problem with this is because with some of these, there are choices. You can do the conditional, you could do the unconditional. It's just you can't do both at once in the same argument and expect to get something out of it. And Birnbaum's argument actually requires that you do conflicting things, that you condition and that you not condition in the same time. So anyway, this has had very dramatic results. It's still found in many textbooks as a theorem, and I'm saying that it isn't, but it has this very interesting logical sort of equivocations and fallacies in it that that make it quite intriguing as to why it has seemed so persuasive, despite the fact that there have been a lot of criticisms of it that are close to mine, that are similar. I'm not the first person to criticize this.
Hello, can I ask a quick question in relation to this? Hello, it's Margarita. Sorry, my camera is not working. But so as you, can you hear me? Oh.
Who is it? Who goes there? No, who's speaking?
Margarita, can you hear me?
Hi, Margarita. I thought it was you.
Okay, so it's a very quick question, but so in a recent paper, you probably know that this guy called Gardenbacher accuses you of, well, basically begging the question in your response to Birnbaum's proof because you're presupposing a frequentist approach. Now, I don't think that's the case. I'm completely persuaded by your objection, but I would like to know how you would respond. He claims at the end of the paper that you responded that Birnbaum's proof is irrelevant to a sampling theorist if it requires assuming that sampling distributions are irrelevant to evidential meaning, which I agree with you. But then he claims that his proof does not require that assumption because each of Birnbaum's premises is compatible with the claim that sampling distributions are relevant to evidential import. So the fact that they're not jointly compatible with the assumption is not an objection to Birnbaum's proof. It is the whole point of Birnbaum's proof. Now, that's what he says. And I would like you to simply...
I'm happy to. Thank you. And I'm glad that you reminded me the other day about this. Of course, as I emphasized, it's everything to do with the proof that he wants to show that it holds for sampling theorists that Bayesians and likelihoodists have much simpler ways to derive the likelihood principle would never appeal to imaginary mixtures or anything. And so here's what Gandenberger says, the person that she's referring to. My remarks, he says, are completely true for something he calls the operational sufficiency principle. That would mean actually applying the principle. I don't know what an unoperational one would be, one that you never apply. It's true that Birnbaum wants his derivation to hold for any account. It's a universal generalization. The other thing that makes this so interesting, I think, for logic people like me, because as you know, the only thing you have to do to show an argument is invalid. You've got this universal generalization that is claimed to be shown. You just need to find a single case in any inference school of any likelihood principle pair, okay? Where even though you hold on to sufficiency and conditionality, you do not have equal inferential import. And that's all you need to show invalidity. Now, the fact that you say, look, it would be fine for somebody or for some cases where there are no LP violations, I say that too. But if you're going to start a proof of the LP by saying, my proof will hold in all those cases where it holds, then that's not a very good argument. That's a kind of begging the question argument, right? Like saying, you know, my vaccine works just wherever it works. So I think this is a pretty shocking, very surprising criticism coming from him, because Greg actually did some guest posts at around the same time on my blog, and we talked about this over and over again. If Birnbaum was only interested in showing the likelihood principle holds for accounts that are already accepted, he never would have gotten the breakthrough honor. That's not, he wouldn't have had Savage saying, wow, this is monumental, because I don't think frequentists are going to stop now at the halfway house with likelihood. They're going to go all the way. Is that a satisfactory answer to, so?
Yeah, no, I am satisfied. I'm just a bit confused by the line where he's just what he says, that the premise, Gardenbacher claims that the premises do not presuppose, each of Birnbaum's premises is compatible with the claim that sampling distributions are relevant to evidential import. And then he says that the fact they're not jointly compatible is the whole point of the proof. So I don't know, I guess maybe I don't, I understand what you're saying, I'm completely on your side, but I guess it's that sentence that confuses me. And
well, you know what, you should look at it again, because I specifically say that it will go through if you exclude any LP violations.
Yeah.
But he would never have bothered, and nobody would have given him a medal, Birnbaum, for preaching to the choir and giving them a convoluted proof that only takes a couple of lines in Bayes' account to derive the likelihood principle. And I do it in like 1 page in my book. Okay. He very specifically, and he was surprised, Birnbaum, that it seemed to be something that would follow for sampling theorists. He says he wants to give an argument that's relevant for sampling theorists and approaches that are independent of the Bayes principle. That's why it was a landmark. So I agree, but it's not much. It doesn't say much for the proof for the likelihood principle if you have to assume it to begin with.
Thank
so
you.
Go back and look at it again now that you've seen this, because it's a wonderful puzzle. And it dawns on me after you mentioned this the other day, Margarita, that there's a nice little publication note if you want. He doesn't even cite my 2013 or 2014 papers. I don't think that's relevant for this point though, but it is a little strange. This is in the British Journal, and I just never bothered about it.
Yeah.
But somebody else might want to write a note on it. Get it published in British Journal.
Good.
Or maybe I will.
Could I please ask a small question of clarification?
Sorry?
Hi, it's Robbie. I posted in the chat.
Hi.
So yeah, I'm not super big on statistics, so apologies if this is a bit basic. That's why I posted in the chat initially. But I'm still a bit confused on one of the more fundamental premises in the argument, that if you have an LP pair, like X star and Y star, why does it necessarily follow that if the pair have proportional likelihoods, that they have evidentiary equivalence? I think I might just not be completely sure on what we mean here by proportional likelihood.
That's the likelihood principle. That's what it asserts. You could substitute one for the other. Similar to how you could substitute insufficiency, if you have 2 equal values of a sufficient statistic, you would get the same inference, at least with respect to parametric inference. That's the statement. And if you did want to see simple proofs about how it follows from likelihoodism or Bayes' theorem, you could look at my book. I don't know if you don't have a copy, I can send you the links to the first excursion that shows this. So it folds out from inference by way of Bayes' theorem. that if you have an LP pair, that the two are evidentially equivalent, at least with respect to informative inference about the parameter and all of that. Given the model, all the givens, yeah.
Cool.
But intuitively, yeah, I mean, I agree. It's not a very intuitive principle.
Yeah, well, it's like the p-values associated 0.05 and then 0.55 and come from, you know, very different parameters. So the idea that they are proportionally likely seems wildly unintuitive, I guess.
Wait, why did you say they were different parameters? Because we were imagining it was the same parameter, like the mean of a normal distribution.
Oh, so, yeah, so I'm probably misusing the word parameters. I meant in terms of like context. It's like one was decided on an optional stopping rule, the other one on a fixed sample size.
However, the interesting thing is you'll see these cases of LP pairs do differ only with respect to this coefficient. And if you look at the likelihood ratio, the coefficient drops out, cancels out.
Okay, interesting. Thank you.
Okay. At least in those cases where there are LP violations. Are there other, I know I had said 12:30, I was trying to keep this as close to the time that we normally have, but I'll take another question if there is one.
Hello, this is Shabnam. May I ask a question?
Sure. Hi.
So I completely get your proof. This is not a theorem. I don't want to argue with that, and I have no doubt. Beautifully shown. However, I want to go back to what I learned from you many years ago about the generation of experimental knowledge.
Generation of exponential. I just wanted to hear that right. Oh, okay.
Yeah. And tell me what I'm missing here. Maybe I am missing something. We have inductive reasoning and we have deductive reasoning. So you showed that the deductive reasoning here is missing and therefore it's not a theorem. But in terms of we follow certain reasoning and then we want to generate some sort of knowledge, if from experiments we are after generation of, if that is a term, inductive knowledge by inductive reasoning, does it really, can we still say that some sort of knowledge has been generated, although it does not meet the criteria of validity and soundness at the same time? And since we're talking about different experiments and then inferring something from them, then we are still ending up with some new knowledge that is generated?
Yes, let's not confuse the argument of Birnbaum's, which was supposed to be a deductive argument, from inferences within statistical accounts, which involve, I think, deductive components and inductive ones. So if we have a significance test or some other, an estimation or a statistical reasoning, we'll go from, let's say, very small p-values to saying there's evidence of some inconsistency, let's say, with the null hypothesis, which is actually an informative inference. So you could say it's evidence transcending. You could say that it's inductive. Okay, but this business of Birnbaum's, which I guess is kind of unusual, is where he's doing this meta work and giving us an argument. And he could have said, I just think intuitively we should accept the likelihood principle. And that's what a number of people do when they think they're defending him, whereas he actually puts it forward as a formal theorem. So I don't know if that answers your question. Yeah.
Yes, yes. So if he were to say something along the lines of, it is still informative, but not in the deductive manner, and therefore didn't name it a theorem, we had something.
Yeah, but again, don't confuse those two. He could say, of course, I can't derive the likelihood principle, but it seems like a plausible idea. After all, he said the conditionality principle really was not mathematical, that it was a matter of what seemed intuitively plausible. If you know you've got the data from this one experiment, that's the one you should use in drawing your inferences. And he said that's not mathematical. He was right, that that itself is kind of intuitive. And there are contexts where you would want to use the convex combination. And so it's a matter of choice. I had another good example where Layman is saying here that there's a question for a given test or confidence procedure. Should level, power, confidence coefficient be calculated conditionally or unconditionally? So it's not hard and fast. And they suggest the answer cannot be found within the model, but depends on the context. So there is this feature of this whole argument here where we're dealing with some principles that are themselves not mathematical. And that's why there is a choice, as Cox said. Maybe if you're only interested in long-run acceptance sampling, you do want to average the precision of your tool. So you have this choice, but what you don't have, and I've never seen any school advise you to apply principles inconsistently, both averaging and conditioning. And yet that's what what Birnbaum's derivation winds up asking you to do. So that's a good one. That's a good point to stop on, I think. So I will end it there. And please, if you have any questions, I forgot to say this last time, you should write them in the Phil Stat Wars blog. This post, the post that you would have gotten information for this, and you can say, I didn't understand, or whatever you want to ask, okay? I'm going to thank Jean Miller for helping with all the organization, and Brian Durazio for filming. Oh, and there will be, or recording rather, and it will be put up shortly. And I'm extremely happy with all of you for being interested in this.